Okay, here we go. Welcome to Monday, your last Monday. Your last Monday in January, February, March, April, May. That means there's only 4 more months left in your, for some of you, 4 more months left until high school. Wow.
I want you to get the intro again.
All right, listen. As bad as the last couple weeks were in your mind, time to start from scratch with a new chapter. Hopefully this chapter goes better. You'll have opportunities. I'm going to be giving you worksheets here and there, going back to the basics for an opportunity to get that down. Chapter 6 revealed so many, to use sports analogies, fundamental flaws that I'm going to be giving you worksheets maybe once a week to make sure. What do I always stress? The fundamentals of algebra are this, that you combine like terms. So if you got x terms, combine them. How do you combine like terms? If the signs are the same, just combine them and use that sign. If the signs are different, find the and use the sign that goes with the larger one. And then the other one's like this. When you're trying to solve an equation to get down to what does n equal or what does x equal, you have to isolate that x by unattaching everything they've attached to it. How do you do it? How do you undo it? You do the opposite of what they've done and make sure you do it to both sides. So in about 40 seconds there, I summed up really all there is to know, except somehow that's being lost. It's like you're trying to play basketball and you're forgetting how to dribble. You can't just run down the court.
You can't really forget.
Fundamental part of the game we're still missing. All right. Chapter 7 about this thing called ratios and rates. Please stop talking. Those two words look very familiar. They both start with RAT. So a ratio is a comparison. A ratio is written 3 different ways that you'll find at the bottom of page 317. You use division when you're talking ratios. Division is a way to compare numbers. Compare 81 to 9. How do you do it? You divide 81 by 9. 81 is 9 times 9. It's 9 times larger than 9. So think about division in a different way. Use division to compare things. Ratios are a way to compare. You can write it as a division problem with a fraction bar. Some of you that aren't doing well, I stand here and talk and look out, and you're not even paying attention. You complain when it comes test time, or you act like you care so much, yet when it's time to learn, you're like, not here. You're physically there, but you're not mentally here. All right, so stay with me from the beginning here in chapter 7. Ratios you can write as a division problem with a fraction bar. There's 2 other ways to write. Let's go down to example 1. A ski resort has 15 easy, 25 intermediate, 7 difficult, and 11 expert only. By the way, if you've never been skiing, don't think you're going to go from never skiing to expert only. Start with the easy ones. Anybody been skiing? Start with the bunny trails.
Oh, yeah.
The easy ones. I've only been skiing once, and it happened to be in the Rocky Mountains. And where they had things like black diamonds, but I didn't do those. I didn't do very well, but anyway. Here we go. Example 1. They want to compare, if you're looking at the bottom of page 317 with me, if you compare the intermediate trails to the easy trails, as simple as this. Look at the information. There's 25 intermediate compared to 15 easy. You write it as a fraction, and then you put it in lowest terms. That's how they got from 25 over 15 if you're following example 1 with me, down to 5/3. They also told you there's different ways to write that ratio. 25/15, or you tell me, how else can you write a ratio? Notice I said, listen to the word I used, 25/15.
The dots.
What do you call those?
Cooler.
Colons. You can write it like this. How else?
Oh, yeah.
How else can you write? They're all the same thing. David. 25 to
Oh, it's 2.
15. However you write it, they're all acceptable. That's the one we focus on because this is what we're used to in working with arithmetic operations. 25 to 15, we said. First thing we did was reduce it to 5/3 by dividing both by 5. Everybody understand? So if you go to the bottom of 317, what if you wanted to compare the easy trails to difficult? Raise your hand. This was comparing the intermediate to easy. Intermediate, easy. Do the same thing with easy to difficult. What would it look like? Yeah.
15.
This is number 1, bottom of page 317. It would look like 15/7 or, go ahead, 15/7 or 15, not semicolon, full colon, 7. Right? Number 2, if you were comparing expert only to easy, what would that look like, Micah? What would my fraction look like if I was comparing expert only trails to easy trails? Expert only? 11 to 15. Everybody see the difference? It's not 15 to 11. If they asked Noel to compare the easy trails to expert only, it would be 15 to 11. That's different than expert only to easy. Got it? Because are these two the same thing? Those are not the same thing, right? So it's 11 to 15, 11, the word to 15, 11:15. Turn the page. How fast were you going? At what rate were you traveling? You've heard that word many times. At that rate, how much would, like, if a dozen donuts are $3, at that rate, how much is each donut? You've done problems like that way back to 5th grade. If a dozen donuts $3, at that rate, how much is each donut? And you would figure it out, it would be 25 cents. You don't have to do that now. I'm just telling you, you've heard these words before. You've had problems like this before, and now we're just reintroducing it. This is kind of review, except we're going to get more in depth. Everybody understand what the word rate means? Rate is a ratio of two different quantities that have two different units. Donuts to money. So in the example I just gave, 12 donuts, $3. How much money would one donut be? 25 cents. And we would arrive at that by dividing both by, how did I go from 12 to 1? So if I divide $3 by 12, I get 25 cents. Do you understand that? I would set up a ratio of donuts to money. And if I want to know how much each donut was, I would divide by 12 because that gets me from 12 donuts down to 1. Does that make sense? And I would create an equivalent ratio. And when I do something like that, that's called, if you go down to example 3, that's called a unit rate. If 12 donuts are $3, how much would one donut be? 1 unit. Not 12 units, but 1 unit. You with me? All right. Let's go down to number 3, bottom of page 318. A water pump moves 2 gallons of water per second. How many gallons are pumped per minute? I'm going to write a ratio of the information they gave me. 2 gallons per second. You should do that on your paper right now. We're going to write a ratio, 2 gallons. We're going to use the fraction bar, not the colon or the word 2. 2 gallons per 1 minute, or is it second or minute? Per second. If it's 2 gallons for 1 second, they want to know how many gallons per 1 minute. How do I get from seconds to minutes? How many seconds multiplied by what? 60. So 1 minute is 60 seconds. So in order to go from here to here to create an equivalent fraction, I'd have to multiply by 60. So what's the answer? 120 gallons. Are you picking this up? All I'm doing is creating equivalent fractions. The information they gave me was 2 gallons per second, so it's 120 gallons per minute. Is that fast or not?
No,
Is that fast?
it makes sense.
No, I'm saying, is that water pump powerful?
No.
No.
2 gallons. Yeah.
2 gallons per second?
That's pretty fast.
Yeah.
That's like, yeah.
All right, number 4. Write 114 points in 6 games. What's his points per game? Put it in a unit. If it's 114 to 6 games, how many points would it be in 1 game? 114 points, 6 games. What would that look like for 1 game? Again, what's the unit here? Game. 1 unit. 1 game. 114 to 6. What did I divide by to go from 6 down to 1? So what must I divide the top number by? And what do you get? 19. 19 points per game. By the way, there's something else you're very familiar with miles per hour. How do people find miles per hour? The same way. You set up a ratio. If you traveled 600 miles in 10 hours, how many miles per hour did you go? 60. 60 over 10, divide both by 10, or 600 over 10, divided by 10. Number 5, 365 people in 5 months. Say, I don't know, you're a person doctor, I don't know, you got 365 patients in 5 months. How many per month? How many per month? If you had 365 in 5 months, what would you divide both numbers by? 5.
73.
73. Number 6, 329 miles, 10 gallons. So your car, if you put 10 gallons of gas in it, it gets you 329 miles. How many miles per gallon? 32.9, rounded to 33. You get 32.9 miles per 1 gallon, dividing them both by 10. Okay, now you go to number 7. So far things are going smoothly, right? You get to number 7, you see a negative number. Why would that throw you? It better not. So you got 49 meters, negative 49 meters, 14 seconds. What would the unit rate be? How many per 1 second? I gotta take 49 divided by 14. What is it?
Yeah.
3. 3.5. Negative 3.5 meters per second. All right, 2 through 22, go. 2
I have no
through
paper.
22, page 319.
You didn't help them all that paper. You just help her.
Yeah.
Imagine this. Imagine this without one. I'm not here. I don't have to do homework without having. Ours is probably a 2 through 40. Oh yeah. Bro, we don't have that. Now I have to do homework.
Okay, cut. Any questions about math only? Yes, ma'am. Shh. She's right next to me. I can barely hear her. Micah, get to work. Always reduce it. So here's what you do for number 2. It's 12 over 36, right? So you're going to write 1/3, 1 to 3, 1 colon 3. That's what they're looking for. Reduce it first. Always put it in simplest terms. 2 through 22.
Not like I wanted to first.
Oh, by the way, 15 over 10 reduced is 3 over 2. Don't be afraid of that. Like when you were in 5th grade, you would always change this to a mixed number. No, we want to keep it a ratio. We want to keep it a fraction.
So what are we doing again? Hello?
319.
All of it?
Keep it up, Rachel.
Okay. All of it? For 5 through 7, just put yes or no.
Yes or no?
Aye.
Is 5 over 2 the same as 20 to 8?
Yeah.
5 to 2 is the same as 20 to 8. All right, in number 9, they got 14 times in one day, and they want to know how many.
14 times. What is 14?
Somebody did something 14 times a day. Doesn't even say. But they've set up a ratio 14 times per day. And then they said that would be 2 times per week. Does that make any sense?
No.
Because they do it more than 2 times in a week.
Exactly. If they're doing it 14 times per day, what did they do wrong?
Times are 14, not.
They wrote it upside down. You have to multiply that by 7 days over 1 week. Because they want to know, they're going from 14 times a day, they want to know how many times that is in a week,
Oh, yeah.
right? So you have to keep you have to go from days to weeks. You have to multiply that by 7 days over 1 week. So it's 98 times in 1 week.
They flipped it all over.
They wrote it upside down.
Which one?
And number 9, that was their error.
Yeah. They did.
So she would just write, you have to multiply it 7 days times 1 week.
What is that?
10 is the same as 2 through 4. You write 33 over 22.
Oh, okay. Can you do 9? We already did this one.
You never did every day. Like you did with that.
Fine. Oh, okay.
33 over 22, you can divide them both by 11.
It's like more than
Hey, I did it. Nothing.
get roasted.
Sure, Nick.
You guys.